Okay, guys, I'm going to demonstrate what I was trying to do in class. It was very difficult to get to each and every one of you. So now, just while I'm home, I'm going to go ahead and demonstrate it. And then at least you'll be able to play back the video. If you missed something, if you're trying it while I'm doing it, then you'll be able to pause the video. And if I leave anything out, please just let me know somehow, either in class or if you think of something later, email me something, uh, because I'm trying to go over it as close as possible, but I might leave something out. So the first thing that I'm going to do, remember, we talked about two different ways that we could measure, right? The standard ruler, which you guys were using the protractor, and then just an index card. Now, I don't have an index card, but this is going to be my index card. It's going to basically serve the same purpose. All right, so let's take a look at the ruler first. If this was a number line instead of a ruler, I want you to try to imagine what the values would be along the ruler. So let's take a look right here. Right here, we're being told that this is 1. This is 1 inch, right? And then over here, this is the beginning. This is the 0 point. All right, so that means that the ruler with the tick marks is cutting the line into equal pieces. This is something that you're very familiar with. You know how to skip count. All right, so if I've cut it into 4 different pieces, then this has to be the quarter tick mark, 1/4. This has to be the half tick mark, right, or 0.5, 0.25. And then this last one has to be the 3/4 tick mark, or 0.75, right? So you use whatever you're the most comfortable with. But be able to recognize both, because they might tell us, hey, this measures 1.5 inches or 2.5 feet, 3.25, right? So be able to go back and forth, be able to recognize each one. Okay, so now if this has been cut into 4 equal pieces, right, the elongated tick marks are telling us that those are the fourths. 1/4, 2/4, 3/4, 4/4. Okay, 4/4. That's one whole. Now, if I have 4 sections of 4, that's a total of 16, isn't it? 4 by 4 is 16. That means that when you're measuring, right, all of these tick marks right here, and remember, this is the inches side. I'm going to go over this side as well, but we're on the inches side right now. So if you are falling short, which we're going to do, I believe, for the base, right, then you're going to be able to find the value, because you know that the full inch is 16 tick marks, and you'll be able, like, let's say if it landed right here, well, that's 4, 8, 12, 13. That would be the 13th tick mark out of a possible 16. And then what you can come over here and do is you can say, okay, well, what's the value? What is 13 divided by 16? Turns out to be 0.8125. Now, you don't have to put that. You can estimate, right? So now you know, because we're going to be estimating, there is going to be what we call a margin of error. There's going to be reduced accuracy because we have to estimate, and because maybe when we line up our ruler, maybe we don't, necessarily measure accurately with the tick marks, okay? So there's going to be loss of accuracy here while we're measuring. There's going to be loss of accuracy when we're estimating our values. Okay, now that's the inches side. Let's take a look at the other side, right? Because the protractor had the same exact measurements at the base, right? You're gonna see that there's a little mm here for millimeters. However, the millimeters is referring to the tiny ones here. So if you recognize, there is an elongated one here, an elongated one here that matches it. So for this side, here's my 0 point, no millimeters. And over here, I have 1 centimeter. This is 1 centimeter. I know this because 1 inch, okay, 1 inch is 2.54 centimeters, 2.5. This is a half because it's elongated. You'll notice right here, your 1 centimeter is cut strictly in half. Half on this side, half on this side. If you count these tick marks, it's 10. right? Because it's going to take 10 of the millimeters to equal the centimeter. All right, so now again, you're going to be able to do the same thing. You know that the total now for this side, if you're ever using this side to measure, the total will be 10. So if you fall short, maybe you fall right here, right after the halfway mark, then you know that that is 6. And 6 out of 10, that's a lot easier than this one. 6 out of 10, you know, is just going to be 0.6. Now, if you don't know that, that's okay too, because you could just do 6 divided by 10, and there you go, 0.6. Hopefully you could see that screen. I'm not sure. But it would be helpful if while you're watching the video you have the measuring tools in front of you and your calculator so that you could be testing this out and not just watching. You can't just watch your education, so try this while you're watching the video, please. Okay, now that we've got the measuring tools kind of figured out, right? Because there's really nothing to figure out about an index card or a piece of paper. It's blank until you put something on it or use it the way you need to. Okay. So now the whole point of this was to measure. So let's start measuring. I'm going to measure first with the inches. And I think I'd have to say at least, I say at least 10 of you I think got it for sure. Maybe more of you got it, but I have not been able to walk around for everyone. So let's just see if we could do this together and get this done. All right, so what you have to be careful of is that if this is the 0 point, that this is what you're lining up with your edge. Okay, you don't want to go flat over here because this is not even counting yet. This is not the 0 point. 0 point is where your tick mark is. So be careful when you're measuring. It'll help reduce your margin of error. Okay. All right, so I'm going to leave some space here because I want to make sure that you can see where I'm lining things up. And actually, this is right here in the halfway mark. So you notice between 1 and 2, this is landed right in between. Now remember what we did here? As if it was on a number line, the halfway mark, half, 0.5. Okay, so now this tells me that this side length of the triangle, in other words, the height, has to be 1.5 inches long. Pretty straightforward. Okay, now let's do the base. Line it up again. Keep it straight. This one's not so nice, right? Because this one is kind of actually in between this tick mark and this tick mark. They didn't make it to the 16. Somewhere between 14 and 15. So if you want to, you can go ahead and say 14.5 divided by 16. You could try that, which is not too bad because that's a 0.9, 9/10. Okay, so we could go with that. If some of you chose 15 out of 16, you also are going to get 0.9. So even though there's a margin of error, we also have some room for that margin of error to, you know, kind of agree with our numbers. So this length is 0.9 inches long. Okay, now let's measure the hypotenuse, which is the longest side of the triangle. This one is actually also very nice, right? Because you'll notice that from start to finish, it's finishing here at one of the elongated ones. And if I'm going to take you back to our number line here, that third elongated line, that was the third segment of 4. That's the 3/4 or the 0.75. So that means that this side length is 1.75 inches long. Okay, all right, that's inches. Now I really don't think that I have to show you the centimeters, but I'm gonna do it anyway because it's good practice. All right, and if we can get you rulers as opposed to the protractors, you'll be able to pick the side that you're the most comfortable with. All right, so this side, if we line it up very carefully, okay. So this one doesn't look like you would think that it would be 4, but it falls short of 4. It's right before 4. So I would go with, let's just make sure that's lined up. I would say that is, we have 3 full centimeters, and then there's 9 out of the 10 tick marks it takes up. So if we were going to do centimeters, this would be 3.9 centimeters. Sorry for the shadow, but hopefully it's not too much of a distraction. All right, here we go. Line this one up. And for this one, we have 2 full centimeters, and then 1, 2, 3 more. So that is 2.3 centimeters. Now you might be saying, Miss Leggett, how come you're not doing the fraction? 3/10. Remember when we were working with the centimeters, the whole was 10, right? 10 full tick marks. And I measured it to be 3 out of 10. That was the spillover or the leftover, 3 out of 10. Well, if I do 3 out of 10 in a calculator, it's just 0.3, okay? So maybe that's one of the reasons why you might choose to measure in centimeters, because there is no, oh, now I have 13 out of 16. I got to figure that out. It's this really weird number. I got to estimate 0.8, like, so you pick what you prefer. But just know that if you're on the inches side, you can't just say, oh, it's 13 tick marks, so it's 0.13. No, that's not how it works, okay? All right, I think you got it. If you didn't get it, rewind it and watch that again, okay? Or rewind the beginning to where we were looking at the ruler. All right, let's do the last one, because we're almost there to the whole point of this. And this one was finally nice. This one is a full 4, and then it stops here at the halfway mark between 4 and 5. So I can say that this one is 4.5 centimeters. Okay, so now you have measurements in both inches and centimeters. And what was the whole point of this? Because we want to take polygon A, which is a triangle, and we want to cut it in half. Now, this was something else that a lot of people were asking me about. Okay, scale factor, by definition, is multiplying. Okay, just like equivalent ratios. The whole point of it is to multiply. However, if you're someone who likes to divide more than you do multiply, especially when it comes to fractions, then it's okay. You can actually take these numbers and divide by 2. So I could take 1.5, I could divide by 2. I get 0.75. So my new one has to be 0.75. Remember, that's my inches. It has to be 3/4 inches tall. So you could look at it as dividing by 2, or you could look at it as multiplying by a half. Because remember, when we were doing our number line, the equivalent of a half is 0.5 or 5/10. Okay? So let's see what that would look like. It would look like 1.5 times 0.5, and you get the exact same answer. So again, this is preference. What do you prefer to work with? Fractions, division, multiplication? You decide. Okay, let's go to the next one, the base. Remember, you have to pick the one in inches, and for me, in inches, it's 9/10 of an inch. So let's take the 9/10, let's divide by 2. That is 0.45, which makes it more complicated, and now we'll introduce some error, because if I estimate that the right way, I would be estimating it to a half. Now, I will say this though. I know that a half of 1 is half, right? And this is not 1. So if you go with the 4/10, you wouldn't be wrong. There would just be a slight margin of error. If you go with the half, again, there's a slight margin of error, because you know that this was not 1. It didn't reach the full count 1 inch. So you know that when you cut it in half, it should be less than a half. All right? Maybe not as small as 4/10, but when you're measuring, that's what you got to keep in mind. Let's do the last one. Remember, it's got to be the inches. The 0.45. Okay, so let's go with 0.45 inches is the base. And then the slant, the hypotenuse, 1.75 divided by 2. Okay, we have 0.875. And if you round that, it would be 0.9. So let's just put it out here. 9/10 of an inch. Okay, and now we can construct it. Let's make sure that we only go 3/4 inch tall. Now 3/4 inch, now this is the other part where you have to apply what your knowledge of where you are on the ruler, right? So it might be better if for your visual that I go from bottom up like this. Okay, so when we do this, we're starting, remember, here at the starting point, the 0 point, and we only go 3/4 of the way, right? That's 3/4. I stopped. Now you see how small that is, right? Well, that's okay because it's supposed to be half of that one. It's supposed to be half of polygon A, right? Let's do the almost half of inch. Almost half of inch. Line that up. Find your half of inch. It's right here. It should be right before it. Right before it. Make my marking so that now I can connect. Okay, now the nice thing about triangles, right, is that triangles, you don't have a choice. You're just basically connecting the dots, right? So that measurement I did for instructional purposes. We really didn't need that one. If all we're doing is constructing a polygon that is half of the original, and I'll call this A prime. It wasn't a transformation, but the whole point of this unit is that we're learning about a different transformation. So I'm going to call it A prime for now. One thing that I would really like you to do before I show you using the index card, I would like you to use the tracing paper that we've been using for Unit 1. I would like you to trace one of them. You decide which one you want to trace and try to map. Draw some kind of conclusion, see if you notice something, and then again, let us know. Make it a point to say it in class. I noticed this, or I wondered that, okay? Because it has something to do with the unit. Okay. Now, last part. Using the index cards. Using the index cards is nice because it can be really time consuming to use the measuring tools. And if you're taking a test and you really don't need to, why bother? Okay? It depends. A half is really nice to work with and you're going to see why. But I think this one was a quarter. This one was doubled. Okay, those are not too bad still. You would still be able to fold this in fourths. Okay, so let's just go ahead and do it. So if you're going to measure using an index card, same thing with the ruler. Make sure that you've got them lined up properly. And all you have to do is make a marking where the height ends. Now you know that from here to here represents the side length of the height of polygon A, right? But they told us to cut it in half. All right, so then I'm just going to take this and I'm going to cut this in half. I'm going to fold it instead of cutting it. And by doing that, I have two halves, don't I? I have two halves. If I have it extended, it's the full length. If I have it folded in half, then I have a half. And I know that this is supposed to be my height. So if I was to draw it, voila, see? If I was to just draw right now, as if that triangle was not there, I would end up with the same exact triangle. That was the height. You can do the same thing with the other two, but you'll say, Miss Leggett, I don't have to do it to the third one because it's a triangle. Now, unfortunately, you're going to have to do it for all of those. And I'm not showing you those because I want you to apply what I've showed you here to these two figures. If they have not come out correctly, if you did not double this one, if you did not cut this into a quarter of its size, then you have to redo it and you have to check it. All right, so here we go. Corner, I'm starting. Here is the end, and again, we're cutting it in half. I think you can see where there would be a margin of error here because these folds will not be perfect. They might be close, but they're still not going to be perfect. There is our half now, extended. It's my full base, but cut in half, folded in half, I should say. It is the base of my new figure. Now see, there's a margin of error there. All right, let's do the last one. I know we don't have to, but the whole point of this is to practice and make sure that we know how to do this. I am spending this amount of time on this because on the Unit 2 test, there is a requirement to do something similar. And there will not be a grid, and there will not be measurements. So make sure that you understand, and if you don't, that you have asked questions as follow-up. Okay, which one was it? I wasn't even paying attention. I guess it is this one. There we go. It's that one. All right, let's cut that in half. Okay, so there you go. There's our extended, the full length of the original. Let's cut it in half, and now that's where it would have been. I'll line it up. Aha, very nice. That one worked. I don't know why the other one didn't. All right, guys, that's pretty much it for this part. I will do a video for problems 1 and 2 because I think people have part of it correctly answered and then partly incorrect. Okay, all right.